Morning, everyone. And the actually my paper, the title of my paper is regarding a company, a kind of case study using the secondary data, applying those machine learning algorithm to review the best product to recommend to the customer. So basically, the title is Reviewing Sustainable Growth of Fitbit, a data-driven marketing approach based on K-mean clustering and collaborative filtering. And right, this is the rundown of my presentation. And let me introduce the company Fitbit. So it is a company-produced wearable device and tracking activities of individuals. Basically, is kind of a sport watch, and is founded by two Americans, James Park and Eric Friedman. So they have expanded significantly, and they are now having more than 1,000 retail outlets in the world. And basically in 2015, it goes public and it becomes a $9.7 billion US company. And in 2021, it was acquired by Google. So basically it helped the company to actually market the product and with a higher penetration rate to the market, and help them to identify the customers, the potential customer, and in the market. And basically, the product actually is a blending of technology and wellness of the users. And it actually track the activity of the users, the heartbeat, the running, lifting, the weight, and also the calories burned during those activities and so on. And we have pulled actually at least 6 or 7 data files from different locations, and then merge these variables together, and then to make it to be analyzable. And these are the major Fitbit product features. So as I mentioned, it help tracking the activities, mainly actually of the user, the individual actually using that wearable device, and the monitoring the heart rate, the sleep patterns, and the blood oxygen level, and the tracking of the location, and so on. So you can also use as a payment device, like your phone. Actually, you can use it to pay when you buy things in the retail outlet. You can use it to pay, settle the payment. And this is the functions integrated in the wearable device. So basically, it's just like a watch you put on your wrist, and there are so many functions tracking your sleeping pattern, your sleeping time, and you are jogging or running, and then track the pace, and also the heartbeat and oxygen level and the breathing, and all these kind of the biological responses can be tracked and logged in the device. And basically, and also these data log are actually can store in the cloud. So here is the objective. So we aim at developing a customer-centric marketing approach, but it's not actually based on the customer age, customer the demographic characteristics. It's based on the usage pattern on using these wearable device. And actually, we do customer segmentation based on these activity patterns, and recommend appropriate products of Fitbit to these customers. So I think, I'm not sure whether you can see the chart, and it's quite bad. But anyway, the process kind of standardized from data collection, research design, and prototyping, and then we use the design algorithm, k-mean clustering, and the collaborative filtering. Basically, we use KNN, the classification approach, to help recommend the product to the customer. And finally, actually, we at the end of the project cycle, is the deployment to the field. And here is the data retrieval process. Is actually mentioning about the steps on how to pull all these different data files together and then combine it into a single data file and do the data cleansing and removing empty fields, and also fields that is not containing duplicated fields as well, containing invalid data, etc. So as I mentioned, there are two machine learning methods we use here. The first one is customer segmentations. We use k-mean clustering. This is unsupervised learning
Excuse
method.
me, Doctor.
And we use KNN to recommend product. And so actually there are different similarity calculation method. So cosine and cosine similarity and the Euclidean distance. So basically, I think for this kind of product recommendation applications, most
Excuse me, Dr. So. Dr. So, the slides are not moving.
Basically, and I think they are these kind of recommended system, or you can call it the applications of machine learning in realizing the AI applications in the real world, and like Netflix, like YouTube, like you purchasing some product on Amazon, like purchase book on the top left hand corner. Actually, it's Amazon website making recommendation. Okay, you buy a book, and then they search the database and then find a customer of similar purchasing pattern or purchasing behavior and recommend the book that may arouse your interest, and so on. Actually, like on the right hand side, actually is Netflix recommend a movie to you, and at the bottom one is YouTube recommend the video that also arouse your interest.
Sorry to interrupt.
So basically, the objective is to improve customer experience and retain customers, and then analyze the customer purchase activity and recommend the proper product to them. And this is the objective. And here is the pipeline of these recommended system. So basically, quite standards starting from data collections. And then the ETL is kind of a BI process. Extract and load, and also building the model, and then load final data to the server layer, and then recommend the solutions, or recommend the product to the customer.
Dr. Stuart, can you hear us?
There are different types of a recommender system.
Dr. Stuart, can you hear us?
Collaborative filtering. There are other types such as content-based approach, and hybrid approach combining content-based and the collaborative filtering. This is the architecture of content-based filtering. You need to have a user profile, and you need to understand the product feature, and so that actually you can recommend. I will show you in detail, how actually using the product feature to recommend a product to the customer later on. And here is a little bit complicated. So there are other criteria added to the systems. So you can see at the bottom, there's a knowledge model. It's kind of a decision tree, but actually depends on the type of application. It's not the bigger the better. So here is a combination of a hybrid system. And this is our system, basically using the collaborative filtering. and you need to have a community data, which is the okay, remote control of your screen. Okay, right. So anyway, you can regain control anytime. Who is going to take over my screen? I don't know. Somebody else want to share something? So you are interrupting my presentation. Please don't do that. And we move on.
Professor?
So
Professor,
here
your
are
slides
the
are not
three
moving.
most common recommended systems: content-based recommendation, collaborative filtering. There are two types of collaborative filtering: item-based and user-based. Our is user-to-user similarity for collaborative filtering. Right. Let me talk a little bit about content-based filtering. It doesn't care about the customer. And basically, but let me put it this way. Okay, so if you rate the product, okay, by in terms of okay, a movie, you rate you want Brad Pitt's movie, and then okay, based on the product characteristic, okay, Brad Pitt has so many movies, and then based on the product feature, okay, the recency, the date, and your preference, whether it is a horror or other kinds of movie, and then it recommend a proper type of movie to you. And Babel is one of the movie that actually played by Brad Pitt. So here is the object, for example, okay, a music a CD, and here are the object informations. So the singer, the composer, and language, year, so on. And then these are the product features you need to identify for making comparisons, and okay, how much similarity to recommend other product to your customer. Here is the matrix you need to build. It's called similarity matrix. And of course, the diagonal is the same product. You need to cross it out. So, and actually you compare the product, okay, item by item. Here is the standard weighted function. So basically you give the score of the product, your preference. So here is the output of the weighted function of certain products. So you actually you can see the range is actually ranging from between 0 and 1. So here, okay, you remove the similarity value, which is smaller than, actually the smaller ones are among the 5 numbers, because actually this is the KNN method, K nearest neighborhood method. So basically you choose 4 items. Okay, you set the K the constant, you set the K value, and then okay, the system or the algorithm automatically pick 4 items that calculate the distance. And you may use cosine similarity, or may use the Euclidean distance. So, and then you obtain the similarity matrix, and then you drop out the lowest one, which is less similar. So basically, this concept of content filtering. So this the following one, which is the type of recommender system we use here, is the collaborative filtering. So the basic idea is, okay, here are the 2 customers. Basically, they have a similar preferences. And then, okay, so the guy who is standing and has similar preference to the guy riding a bike, and he liked a dish of something. I think it's kind of meat. I don't know what it is, but and the other one is pizza. But the guy standing, actually he has a preference. He like to drink a soft drink, like Coke or maybe Fanta. So you may recommend, okay, these, you assume that, okay, they have similar preference. So, okay, you assume that, okay, the customer who is riding the bike may also like to drink this soft drink as well. So you recommend this soft drink to the customer riding the bike. So, okay, basically it's all about how to calculate the similarity and also the score the customer that he gave to the product. Okay, he purchased before. And basically there are two types of collaborative filtering. So actually we implement the one in the left hand side, user to user based filtering method. So you can see, okay, so the guy and the girl, the first and the third, basically they have similar preference, but the girl prefer this, I think it's orange. So you recommend the orange to the guy, the number 3 customer, based on this assumption. So I think the concept is basically the same, and I show you using the similarity matrix. So using Jane and Tim as an example here. So they actually also have similar purchase pattern. They buy the same product like item 2 and item 3, but actually Jane liked, okay, they prefer item 2 and don't prefer item 3. Put it this way. And Jane like item 1. Okay, you can see the smiling face here. And so you would recommend, okay, item 1 to Tim, because assuming that, okay, they have similar purchase pattern or similar preference. Here, as I mentioned, you need to have a similarity matrix. You draw a matrix showing, okay, in one dimension, summarizing the product they will or they have purchased, and the other side, which is the vertical axis, is the customer. You want to make comparison. So this is the history, and based on the record you extract from the database. And then, okay, based on this pattern, you start build a matrix like this. Okay. So here, I want to recommend some new product. Okay, to customer 1. I will show you later on. Okay, how, and let me finish this process first. Okay, you build a matrix, implement in your program. We use Python, and so, okay, now we actually represent, okay, dimension and matrix in this matrix. So basically, it's a 2-dimension matrix. So how to actually review the similarity? So you cross out the angular because actually they are the same user. So we use cosine similarity. So basically the principle is, okay, the value ranging from between 0 and 1, and the higher the value you compute, actually the higher similarity. And actually the cosine function characteristic is, okay, the smaller the feature, the smaller the angle, okay, you get the higher the value, the higher the angle, okay, the smaller the output is, which is the similarity is lower. So here is the similarity of between user 1 and user 2 based on the cosine function. So we calculate all these similarity constant or similarity values between different users. So this is the KNN approach. So the concept is, okay, we choose, okay, you assign a value first, okay, 3, 4, 5, whatever, you name it. Okay, you assign the values, for example, like 3. You choose 3 items that is closer to the central or this user that you want to recommend. So basically, we want to recommend some product for user 1. How much time do I have? Okay, I need to speak up. And basically, you can see after sorting, you can see, okay, the smallest value is 0.25. Okay, so since k equal to 4, we choose for nearest item that is very close to the preference of user 1. And that's why we drop the smallest value, which is 0.25. What did they purchase? Okay, you can see the matrix here. And user 4 purchased these 3 items, user 3 those items. Okay, it drop out because actually if you go back to the slides I showed you before, you find that okay, user 1 has already purchased this item. You don't want to recommend the same item that he purchased before. You want to recommend something new that he wants to experience in the future based on the preference of other customers that we sharing similar preference to user 1. Now, okay, there are 4 items here, okay, that user 1 hasn't purchased before, okay. And we calculate the weight of these 4 items, which is the score, and basically assigned to the new product, okay. So other method, okay, calculating the similarity measures. So Euclidean distance is another common method here, or Pearson correlation coefficient. So there's actually advantage of collaborative-based recommender system over the content-based because okay, it is easier to implement, and the prediction is more accurate. Here's the result of our product characteristic. And basically, we do the cluster analysis, and we divided the activities into 5 clusters. And basically, we monitor things like weight, and calorie burn, and also the daily activity they engage, and also monitoring the heart rate pattern, sleep duration of each activity level, and also the step the user was in each activity. And the others dimension is sedentary, which is basically they don't do much exercise, they just sit there and watch, and they do a lot, that is a lot. And here, lightly active, and the third column is moderate active, and the fourth column is very active. And okay, here is the product feature, okay, that you will use to do the calculation. And basically here is the intensity of the measure, okay, and based on the similarity ratio, the similarity equation we proposed, it's a cosine similarity. So here are the product we recommended. So some of the similarity actually we set the algorithm in this way. If the similarity value lower than 50, we actually think that okay, or we assume that this okay result is not reliable. We don't recommend any product. Instead of conveniently recommend something to this customer, we just don't recommend anything to him or her. That's why some of the cells are empty because actually their value is lower than 50. So here come to the end of representation. So it'll be fast and earlier than the finishing